Hello everyone. The topic of my presentation is order picking in warehouses. Order picking in warehouses. The problem statement of my project is, as we know, the warehouses are essential component of supply chain and order picking activity lies at the heart of logistics. Warehouses are used to store high volume of products and it's an important part of supply chain for any industry. Typical operation at warehouses are involves receiving of goods, arranging in shelves, order picking as per the customer demand, packing and shipping. Warehouses are not just a storage facility, but it's an value addition to the facility. The main activity of warehouses operation in terms of time and the cost of labor is picking, is order picking. It consists of collecting of different set of products as per the customer demand. The order picking in the warehouse consists of 55% of the warehouse operational cost. It can be concluded that traveling consists of biggest part of order picking cost, which is the most expensive part of warehouses operating. The challenges in order picking, as warehouses stores large amount and large volume of various products, and picking products from different places consume so much of time of picker, and unintentionally a picker has to travel long distance, which can be reduced if an optimal path or an order of picking item can be provided to the picker so it can reduce the picking time. Now we'll talk about the layout of warehouses. Depend on the industry and companies, everyone has a different layout. Picking time can also be reduced if the products are arranged in a certain manner like ABC analysis and can be used to store the products. Like we consider the fast moving goods can be stored at designated places. There are many methods available for zoning of product. If we arrange our product in certain fashion, then we can reduce the travel time of the picker. Now we will discuss about different routing paths for a picker which are available. The first one is the S-shaped path. It means that any sub-aisle contains at least one product will travel the entire length, and sub-aisle where nothing has to pick can be skipped. The next one is the largest gap. In this method, the picker will go to the farthest block first and then proceed block by block to front of warehouse. The largest gap means the largest of all gap in sub aisle. The next one is aisle by aisle. The order picking route from this heuristic is that picker visit every pick aisle exactly once. Like first it will pick from the first and then second and then third and then so on. The next one is the optimal path. The routing of order picker in warehouse is a special case of TSP. The objective is to reduce the travel time and the picker has to move as little as possible. As discussed in the previous slide, that optimal path is which the picker has to move the as little as possible, and in my solution of this project I have tried to find the optimal path there so that the picker has to move as minimum as possible. So the formulation and the model I have used, the first I have used the Djikstra algorithm to find the minimum distance, and then I have used the GG formulation to solve the TSP, means to find an order in which the picker has to collect the product. For the Djikstra algorithm, I have written a code in the Python, and the shortest distance between each of the node has been calculated, and that serves as the cost matrix for the TSP. Then I use the GG constraint to find the optimal path in which the picker has to move, and the GG constraint formulation is solved by the Gurobi, and the 15 I have used the 100 products in the warehouse, and from that a picker has to collect the 15 products. For the experiment part, to gain the insights of the project, I have considered two types of distribution and design layout in the warehouses. The first one is the random distribution and the second one is the symmetric distribution. In the random distribution, the distance between each of the product is between 1 to 10, and in the symmetric distribution the distance of each product from every product, it's changed and it's in an increasing order. The experiment has been done on the 100 different products are there in warehouse, it has been assumed, and the customer needs 15 different kinds of product. The solution of this is done by using the Gurobi solver, and the shortest distance is been found by the Djikstra algorithm, and in both of the cases the optimal solution has been found, but the objective value of the function is more in the case of symmetric distribution and less in the case of random distribution, because the distance in the random distributions were very less and the distance in the symmetric distribution was very high. The result is shown in image is the optimal solution and path is given to pick the products in the both the cases. The time taken to solve the problem through the Gurobi solver is 0.56 seconds, and the problem can be scaled to 200 to 300 products in the one go. This problem can also be solved using the dynamic programming, which also gives the fast results. For the future work we can solve the problem with the cross aisle and the multiple aisles. For the path here we can discuss for the random distribution, a picker has to start from the depot and then it can goes to the path which is shown in the image and again returns to the depot. This solution, the path, both the cases the picker start from the depot and again returns to the depot. This project helped me in strengthening almost all the topics I taught in the class. The project helped me in learning new concept, researching about the problem statement and its solution thoroughly, interacting and discussing with professor and batchmates regarding the different projects, and the solution to this problem has been an amazing experience. I would like to thank Professor Cyrus for giving me this opportunity. Thank you.